inclined plane problems. And in this problem here, we've got a block that's placed on an inclined plane that is 42.4 degrees from the horizontal, and we're being asked to find the acceleration of the block. So let's go ahead and draw this block on a plane. There we go, on an inclined plane. So that's my block. It is 42.4 degrees, 42.4 degrees from the horizontal. And we need to find the acceleration. So acceleration is really the question mark. Now I know the acceleration is really equal to the force net in the x direction, right? And here I'm going to really say, okay, well, in this x direction, I'm going to call this my x direction, and this is my y direction. I'm really going to put it on an angle because I kind of want to level it to the object here, right? This object that I'm talking about here. And it's really mass times acceleration. And I know the mass, right? I'm given the mass. So I really just need to figure out force in the x direction. And how do I figure that out? Well, in this diagram, I hope that you recognize, and I'm just going to change colors here, that the gravitational force on this object is acting in the downward direction. So that's the force due to gravity. Now you see it's straight down, so it's kind of on an angle relative to my XY grid. So I have to decompose it into X and Y components, and I can do that. I can put or decompose this into a Y component. There it is, that's my Y component, because remember my Y is now on an angle. And this here is my X component. So I hope that you see that this makes a 90-degree angle. This is my force of gravity in the Y direction, and here's my force of gravity in the X direction. All right, now another force on this object here is the normal force, which is of course right here, and it's perfectly, I should actually maybe erase my grid here, because the normal force should be the exact same magnitude as the force of gravity in the Y direction, so the same as this force here, because they're opposite in direction but equal in magnitude, because the object is not moving above the plane, right? So if it was, it would be moving upwards. If the normal force was bigger, the object would either be moving upward or downward, but it's not. It's actually moving down this way, right? So this is the way that it's moving, and that would be parallel to this force of gravity in the X direction. All right, so the force net in the X direction here is really this force of gravity in the X direction, right? Not just force of gravity, because force of gravity is perfectly downwards. That's not the way we're moving. We're moving on an inclined plane, and that's equal to mass, which is 54.3 kilograms, times the acceleration. We're really looking for the acceleration, and what is it? So, I mean, if I want to think about it, I really need to figure out what is this force of gravity in the X direction. And if I want to look at it, you should hopefully realize that, hey, this angle here is also 90 degrees, right? So like that angle that I've just drawn is also 90 degrees. I don't really need that, but I do need to recognize that, hey, if this angle is 42.4 degrees, this here is 90 degrees, well, then I can figure out that this here is 90 minus 42.4. So this angle here that I'm shading, so this shaded angle here is 90 minus 42.4. And if that angle is 90 minus 42.4, then the angle that I'm about to highlight in yellow, so let me just go a highlighter. So this angle here, the angle here is really equal to 42.4, right? Because that angle, along with the angle that's adjacent to it, must add up to 90. So I hope that you recognize, and that's really important to recognize, that that angle here, the highlighted one, that's 42.4 degrees. That is always going to be the exact same as whatever your incline is. And if I know that, and I have my right angle triangle here that I've made up with my gravitational force as well as the gravitational force in the X and Y direction, I've broken it up into components, I can easily figure out what FG in the X direction is. And I can use my SOHCAHTOA here. If I want to look at it that way, I've got the opposite angle. I know the hypotenuse is my force of gravity overall. So I can really just use sine of 42.4 degrees is really equal to my force of gravity in the X direction divided by my hypotenuse, which is force of gravity. And force of gravity is really mass times g, the acceleration due to gravity, right? And that's precisely what I can multiply both sides by, and I will end up with FG in the x direction is equal to F times G, and that's going to be multiplied by sine of 42.4. So Fg in the x direction is really force force due to gravity, which is really made up of mass times acceleration due to gravity, times sine of 42.4 degrees, and that's really equal to mass, 54.3 kilograms, times acceleration. And again, F times G is mass times acceleration due to gravity, times sine of 42.4 degrees, and that's equal to my mass, 54.3, times acceleration. And really this acceleration is what I'm looking for. I'll divide both sides by 54.3, which is the mass. So here, I mean, this is the mass as well, which is 54.3. So I'm actually just going to cancel that and 54.3 because I don't feel like over multiplying. So it's really just G, which is the acceleration due to gravity, times sine of 42.4 degrees. And if I just try and use my calculator to figure out what is sine of 42.4 degrees, it's 0.674. I'm going to multiply that by 9.8, and that gives me an acceleration, which is a vector, of 6.6 meters per second squared. That's it. Inclined plane question.